Can you hear me? All right. Hello and good afternoon. Welcome to the What's Not New in Modular Java talk. I guess most of you have been on the all or most of the Jigsaw talks earlier, or you're familiar with what's going on in Java. Anyone who does not know what's coming in Java? Good. See the right audience. Okay, my name is Milen Dyankov. I work for a company called LifeRay, and we are building a lot of things that has a lot to do with modularity. So obviously we're monitoring pretty close what's going on in the Java, JPMS, Java 9, Jigsaw, whatever you want to call it, world. And so this talk is going to give you a little bit of a different perspective of how the things work, will work, are expected to work. So I go by my full name on Twitter. So whether you agree or not, or you want to argue, or you would just say something, please go ahead and do so. And I'll start by making it clear what I mean when I talk about things that are not new. Okay? Because when I say not new, a lot of people assume that that's not true, because there is obviously a lot of new things going on and coming up in Java 9, and that's totally true in terms of all the tools that and all the API changes and so forth. So there is obviously a lot of new things that will show up in Java 9. But as far as modularity is concerned, and the concept of modularity, there's not so many new things. So think about concepts and solving problems rather than tools and particular implementation. So I've been doing this talk for quite some time, a little bit different versions of it, but the question that made me start doing this talk is, like, is it the right time to talk about modularity? Because we've been ignoring modularity in Java for the last years very, very much. To give you some perspective of time, I think the first attempt to start modularizing Java was around the year 2000. That's as far as I remember, but I couldn't find any written proof of that. So the first thing that you can actually find that is written down as a first attempt to modularize Java, it's in around 2005 with JSR 277 and then JSR 294. And fast forward, 2014, we have JSR 376 and a bunch of JEPs, which is what we are dealing with today and what's going to end up being implemented as Jigsaw in Java 9. So it's been quite a journey. As you can see, it's like, what, 12 years already? So where we are. Let's think is a photo I took 2 years ago, 2015, at Devox, Belgium, where the Oracle folks wrote this on the board, asking, will we be using Jigsaw in 2016? And you can see the answers. The funny part is the OSGI statement down there, which I wasn't the one who wrote it. So as you can see, there is a lot of concerns in the community around modularity. Nevertheless, Java 9 will be released in 70 days from today. That's a countdown that you can find on the internet. So this is going to happen. You may have heard about the JPMS being voted no and concerns some companies have about it. Yeah, there is something going on there, but if you ask me, I have no doubts. Java 9 will show up, Jigsaw will be there, whether you like it or not. It's the right time to talk about modularity in Java in general. But if we want to talk about modularity, we need to decide what we will be talking about. So what is modularity? Do you feel like you know what is modularity? Please raise your hand if you think you know the definition of modularity. No one. That's what I thought. And I'm not surprised, because that's the problem with the whole modularity thing, is it's undefined. Or in other words, it means whatever the person that says the word wants it to mean. And that is why most of the disagreements between people and companies that you see around is happening, because they define modularity in different ways. When Oracle people say modularity, they have something different in mind than people that have been dealing with modularity for the last 10 years and experienced a bunch of problems with it, okay? So how do we proceed if we don't have a common definition of modularity? So there is something that may help. It's known as a modularity maturity model. It was first proposed by Dr. Graham Charters back in 2011, and it has these 6 levels. So basically, it goes, the level 1 is ad hoc, no modularity at all, you're totally monolithic, like you have no idea of anything. So then you have modules, which means you are already decoupling from the artifacts. Then you have modularity layer. Then you have loose coupling, devolution, and dynamism. I'm not going to go in deep details right now, but I'll go back to this. Okay, so what Graham Charters actually did, he actually defined the level 7, which he called Peter Kriens, and it's only available for people who are Peter Kriens. The joke is because Peter Kriens is like the person who is like the lead architect, to say so, behind OSGI. Person has been dealing with modularity for pretty much all his life, arguably a person most knowledgeable in the area, so that's special dedication for him. And Peter Kriens, in this book, Java Application Architecture, which he didn't write, but he wrote the foreword to the book, took on that maturity model and said, well, if I were to define it, I would go with 5 levels. I would go with unmanaged, or house, and then managing dependencies, proper isolation, minimized coupling, and service-oriented architecture. So now you have a little bit of a similar but kind of different 2 definitions of modularity, in particular modularity maturity model. So I was a little bit puzzled which one I should use for the purpose of this talk. What the Java developer, or in general developer, does when they have 2 frameworks to choose from and they don't know which one to pick, they made their own. So that's what I did. So that's my model. It's called buzzword compliant modularity maturity model. And it's largely based on the fact that software development these days is basically based on buzzwords. You go to a conference, you hear about the new cool thing, you go home and you implement it, and it doesn't matter if it makes sense or not for your business. It is a buzzword. Everyone wants it, so you have to do it, okay? Anyone disagrees? This is how we operate? That's what I thought. Okay, so the buzzword compliant modularity maturity model goes like this. The levels 1 is the monolith, the bad guy. No, I certainly hope no one here does any monoliths anymore, right? Okay, so monolith is the bad guy. Then you have the composite, the containers, the discovery, and the microservices, all buzzwords. Okay, let's go into, jokes aside, let's try to figure out what those are. So when you have the bad monolith guy, basically you put everything together in one big ball of mud and you don't care. You have absolutely no awareness of any dependencies or anything because everything's together. It's one big thing all together, okay? Now you realize that's not probably the best way to deliver software, so you want to go on the level 2, which is a composite. And a composite, you start composing your application from bits and pieces. Okay, so your application becomes aware of infrastructural dependencies. So you know that this jar file needs this other jar file, and this other jar file needs this other jar file, and so forth. So it's all on the infrastructure level, like this thing needs the other thing. Okay? Now that's good, but you want to go better. So level 3 is where you introduce functional dependencies, where you start to realize that, well, wait a minute, it's not the jar files. It's about what's inside the jar files. I don't really care about the jar file. I really care about what is inside, like packages and classes and all those things, okay? So you start being aware of functional dependencies instead of being aware of only our infrastructural dependencies. And this gives you even more flexibility in the way you build an application. And then you go one step further and start thinking, well, wait a minute, it's not even about those things that are inside the jar files, but what do they provide? It's about the functionality that they give it, because that's what it is. I'm using the functionality, I'm not using the actual thing. The actual thing is basically a proxy for the functionality that I need. So this is where you enter the high abstract level of actual functional requirements. It's no longer dependencies. You no longer depend on a particular thing, but rather you require a particular functionality to be available for you, okay? And then the final level, microservices, is when you realize that the whole thing, as you see it today, will change tomorrow. And so you decide that it's not just about composing the things together today, but also building it in a such way that they can adapt to changes. So if something changes down the road, your application can actually adapt to that change and still function. So how do we solve those problems with Java today? So on level 1, the monolith, the bad guy, you don't need anything. It's just Java. Put everything together, good to go. The composite thing is solved typically by Maven. And it doesn't really matter which build system you use. You can use Ant or Gradle or whatever it's your favorite one. It basically all follows the Maven dependencies model in one way or another, right? So you have a jar file that depends on another jar file that depends on another jar file. So this is your infrastructural dependencies, okay? So then you want to go more abstract, and you start using things like CDI or Spring or Java EE, which allows you to define components or kind of pieces that you can wire together at some point in time, potentially dynamically. So it is not that you actually depend on that jar file, but you actually depend on that component. Nevertheless, you still need Maven or a Maven-like dependency model to know what to put on your class path, right? So it's a kind of combination of the two. Anyone willing to take a guess what gives you level 4? Sorry? No? Oh, come on, it's easy. Nothing. There is nothing in Java that only gives you level 4. There is this crazy thing called OSGI that covers you all the other levels. And that, because OSGI covers all these levels, that's why you keep hearing how complex and terrible it is. Okay? So the question that you may ask now is, well, wait a minute, where is JPMS? And JPMS is Java Platform Modular System, which is another name for GSR 376, which is implemented by Jigsaw. So we're talking about the same thing here. How does it fit into that picture? Pretty much like this. And you may wonder, like, oh, wait a minute, why is that? The reason it fits like this is the keep it simple rule. And this is one thing that Oracle made it clear from the very beginning, that when they're going to build a modular system, one of the main like goals of that system is to be simple. Okay? And when you want to make things simple, you typically want to leave aside something that naturally makes it complex. So as it covers level 2, it only covers bits and pieces from the other levels, and we go through those in a little bit more details. But first, let's have another example of how an application looks like, and actually modularity looks like from application perspective. So imagine that's your application, Java app. It consists of classes, very nicely combined together, as you can see in the picture. And if you want to figure out like which class depends on which other class, it's a little bit of a challenge. But you can do so. But that's actually a lie. That's not how your application works. It's more like this. So down there is the Java platform that has a bunch of classes that you use. Up there is your Java application that has a bunch of classes that reflect your business functionality. And that big thing in the middle is a bunch of libraries that you use in order to get things done, because obviously you don't deal with the like all the middle layer. You just use libraries for that. Okay. So how we address the problem of this thing being so messy? Well, this thing, OSGI, came around year 2000 and said, we'll try to fix that problem. So how do we fix that problem? Let's start by this layer down here. That's the Jvm layer. So the JDK layer. So there's nothing they can do about JDK because they don't own the JDK. So JDK must stay the way it is. So nothing to do about it, but the tricky part is every single class in Java is loaded by a class loader. So if OSGI can take over class loaders, they can actually arrange and rearrange the way classes are loaded, and then they can influence everything above that line. And that's what they did. They designed a modular system that's totally based on class loaders, and then they rearrange the way you build applications so you have modules, you have nice dependencies and nice requirements and capabilities and things like that, and that makes your application nice and tidy, and you can actually know, and not only you, but like the code, the platform can know what thing depends on what other thing. The question remains, what are you going to do with that middle thing? And the OSGI architects decided that they've designed such a great system that everyone's going to immediately fall in love with, and everyone's going to start building bundles, which is what in the OSGI world is called modules are called. And then we're going to all live in a beautiful place. And you all know how well that worked. So, why it didn't work? Because a lot of people thought that this is a very, very complex solution. And what they failed to recognize is the solution was addressing a very, very complex problem. So if you address a very, very complex problem, it is very natural to have a complex solution to a complex problem. Okay? But it was just much easier to blame the messenger, so that's what you get. OSGI is complex, it's basically useless, okay? Even though there's millions of people out there using it, but main message that you can hear is like, it's complex, it's too complex. So now we have JPMS, and JPMS is basically solving the same problem. The difference is, now the JPMS is delivered by Oracle, which is the owner of the JDK, so they can actually refactor this layer down here and make modules of first-class citizens of the Java platform, and that's a good thing. Finally, someone made a decision to actually do this, which is really, really a good thing. The issue is, they decided that what works for the JDK should work for any application that works on top of JDK. So basically, as far as modular system for applications is concerned, the decision was, well, just use what we have for the JDK, right? It's, there's no difference, okay? Same thing for libraries. Like everyone's going to immediately fall in love with JDK, and we all going to live in a beautiful world. Now, I've been criticized about using the word must in this slide, because it's not totally the truth that you must go with modules. Theoretically, you can still ignore JPMS in Java 9 and go with the class path. Theoretically, because that's up until the moment when someone starts only releasing JModes or things that are totally incompatible with class path, and all of a sudden you realize that because of your dependencies, you're forced to go to the modular side. But it's a different story. Even though, another example is that if someone changes an executable jar file to be a modular one, you can't even execute it later on with java-jar and the name of the jar file. You have to execute it as a module. So if Spring Boot was to change, you would no longer be able to run your Spring Boot applications the way you used to run them today. You'll have to use the new syntax of Java 9. I'm not saying that it will, but just as an example. So it's not that you must really, but you will be be forced to by the environment around you. So the clue is, what's new is below that line. Modularizing the JDK itself, making modulars first-class citizens in Java, that's new. That wasn't there. You couldn't reduce the size of the JDK, and that's new, and that's cool, and it should be there, and I'm very grateful Oracle did it. What's above that line, suddenly not new. It's something that you could have done 10 years ago if you wanted to. If you wanted to build a modular app 10 years ago, you had all the tools to do so. The thing is, you didn't want to, okay? But now, you are being told that you kind of have to, which is a good thing. Forcing people to think in terms of modules is in general a good thing. Now, the thing is, whether the proposed solution actually is a good solution for application developers, because no doubt it's a good solution for the Java itself. Let me quote Peter Krins again, and he says that a lot of people will discover nowadays that their babies are not as modular as they thought they are. And as you've been aware, this already started to happen. It happens to Spring, to Hibernate, to a bunch of other products out there, who all of a sudden realize that, wait a minute, the modularity as we thought of, it's not exactly what this is about, okay? So, why is keep it simple not enough, and when it's not enough? Give you another perspective. We built software much like we build products, okay? So you want to build something, you start with a material, and from that material you make up something like an intermediate product, and then another intermediate product, and in the end you combine those intermediate products and you build something, okay? So say you want to build that robot, okay? What you're going to need is probably a bunch of tools, some software, some hardware, probably computers, so you can program the thing. Okay, so those are your dependencies, kind of like. But then again, for these people to provide you those things, they have their own dependencies. Okay, so they need to use more tools. They're probably going to use some wires and power plugs and you name it, right? So this becomes like more complicated. The more complex is the thing you want to build, the more complicated your dependency graph becomes. And do you think there is a problem with this diagram, or its accurate representation? Anyone spots any problem? No, I'll tell you why. So according to this diagram, the people in here who built, I don't know, some tools, they don't use computers. Do you think that's the case? I highly doubt so. I think they do use computers, so we should draw an arrow from this thing to over there. Well, those computers probably use hard drives, okay? And those hard drives probably need to be assembled by some tools. So if you really want to draw a dependency graph as the things appear in the real world, you would draw an arrow between pretty much any two nodes in that graph. That's the reality. But with software developers. And we know that graphs are bad unless they're acyclic. Okay, so when we model, we want to keep things simple, and we want to model things as an acyclic graph. And then when we model it like this, because it is acyclic, it's beautiful, and we love it. And it doesn't matter, it does not represent the real world. It doesn't matter, it's totally wrong, it's beautiful. Okay? And this is how we build applications. We have an entities. Well, basically, making the whole concept more abstract. We have an entity offers you something, and some other entity uses that thing, and so forth, and we build a product. And that's exactly how we build software. We have artifacts that export some stuff, then other artifacts that import that stuff, and then we assemble the whole thing together and build an application. Okay, let's compare now how both OSGI and JPMS address those concerns according to the modularity maturity model. So, in level 2 is the moment where you want to decouple from the artifact. So you want to decouple from the actual jar file and use modules, okay? So first of all, the packaging is a little bit different. In OSGI, you used jar files, whereas at JPMS, you can use jar files, but there's also a JMode kind of packaging thing. I'm not going to go into details how those differ, but you should stick with the jar. Then you define a module. You give your module a name. In OSGI world, you use manifest MF file. It's textual representation, so you call it whatever you want to call it, and that's it. In JPMS, you use the module info Java instead, which is a Java class that gets compiled. Okay, so that information is no longer available when you distribute the thing. That information is no longer available to anyone in any textual form. Okay, but pretty much same concept. So from that perspective, the level 2 is covered by both technologies. You decouple yourself from the artifact. It's no longer relevant what's the name of your jar file or where you get it from, as long as what it has inside is the proper module. Okay, so both are identical in this sense. Now, level 3, you want to even decouple from that identity. Right? So you want to know what's inside and not what the name of your module. Okay? And so the first thing is the export. So in OSGI world, you have this thing called export package and manifest file, and in Java JPMS world, you would have this exports and a package name. So that's pretty much the same thing. Now the flip side of that is, how do you use something that is exported to you? Okay? So a long time ago, actually it's still there, but it's very, very, the usage is like discouraged and abandoned. In OSGI, there was this thing called require bundle, which was the rough alternative of what JPMS now proposes, which is requires and the name of another module. Okay, so now OSGI uses import package. So basically, it doesn't care what's the name of the other module, but it cares what has to be inside. So you care about the package that someone provides to you, and you don't care about who provides it to you. Okay? Well, JPMS, in order to keep things simple, decided to go with requires another module. And you may think, okay, wait a minute, it's pretty much the same thing. Like, what's the difference? I've been struggling with explaining this to people for a very long time until these two guys, Neil Bartlett and Kai Hegbert, made this InfoQ article where they purely explains why is that a problem, taken from like over 10 years of experience we had in OSGI. So the up there is the before status. So imagine you have a module A and module B, and in the first case scenario, you know that the package from a module B depends on a package in module A, another package in module B depends on another package in module A. That's OSGI. Now, in JPMS, all you know is that module B depends on module A. And that's pretty much the same. Now, at some point in time, you decide that your module A is too complex, too big, and you want to split it into two modules. Okay, that's perfectly fine. You can do this. And now you have A and A prime. And you shift the package. So now org bar belongs to another module. In OSGI world, you have absolutely no issues. You do this, and everything works the way it used to work without anything changing because your dependencies are between packages. Okay? In JPMS world, you have a problem because you don't know now whether your application depends on A or on A prime, because you have no information whether the dependency between A and B was because of the package that stayed or because of the package that moved. Okay, so now potentially you need to refactor also your application B, assuming that you're the author and you can do so, to either switch the dependency or introduce another dependency. Okay? So that is how is that different, and that is why OSGI decided that that's a bad practice and moved away from it. So to better understand this, in an OSGI world, you would basically say, I need a power plug for my thing to work. But in a JPMS world, you would say, I need a foo because I know foo produce power plugs, and I know by the rules of JPMS that foo is the only thing that's allowed to produce power plugs. Okay? And that is kind of a ridiculous rule if you want to put it in real life, but to keep things simple, that's what was in JPMS. Okay? The same thing goes deeper with versioning. So you may want to specify that you only work with the specific versions of power plugs, and you can't really do this with JPMS because JPMS decided to not use versions for wiring things together. So one step further is what happens when you use a thing that uses another thing. Okay? And in NoSGI world, you have this uses statement, and in JPMS, you have requires public, unless that changed, because they keep changing the syntax. I'm not sure what's the latest one, but at some point in time, it used to be requires public. Basically, to tell that, okay, I'm using this module, and I'm kind of re-exporting it to some other people. So basically, in NoSGI world, you say, I build a computer, and to build this computer, I use the power plug of this type, and in case you need it, you know what's the type of the power plug. Whereas in JPMS world, you basically say, to build my computer, I used this other module called foo, and now you're transitively dependent on that other module without even telling you why. So you don't know what's the reason you got this transitive dependency on another module. Okay? So this is level 3, and as you can see, for the purpose of keeping things simple, it doesn't cover all of the cases that you may want to deal with regarding decoupling from the artifact. If you want to go a step further and you want to decouple from requirements and actually start dealing with, from dependencies and start dealing with requirements, it's even more complex, because now you reach the point where you realize that the computer you built doesn't really need a power plug. All it needs is power. So as long as someone can power your computer, it will work. Power plug is mainly the thing that you use to get the power. So OSGI allows you to abstract those and basically say, I have a requirement. I need to be connected to a power outlet, or I need someone to provide me a power. And then it allows you also to say, I provide a capability. So there is another module that says, I know how to give you power. I know how to plug you. I know how to power you up. Okay? And then there is this magical thing called resolver. And the resolver is like monitoring for requirements and capabilities, and then says, oh, you can do this, and you need this, so why don't you guys work together to solve that particular problem? Okay? And that's like a total different level of abstraction. One that unfortunately there's no way for you to achieve with JPMS, because JPMS is so strict on how modules need to be wired together. There is a change in how service loader works. Service loader, what's the proper name? Hope I'm not messing up. The thing that showed up in Java 6, I believe it's called service loader, but doesn't really help you too much. And perhaps some of these concerns could be addressed by technologies on top of JPMS. We don't know yet. As of today, there's nothing that I'm aware of that could help you decouple yourself from dependencies and move to requirements. Okay? So you can't really. The dependencies are the core thing there. Nothing you can do about it. And the final thing is the service layer. So the service layer, as I said, there is this service loader thing, but service loader is also now moved into the module info jar file. So it is like statically wired to particular modules, so you can't randomly load a service unless you first define your proper dependencies between particular JPMS modules. In OSGI world, the service layer is totally decoupled from the architectural layer. So as long as something can register a service in service registry, something else can find and use that service. And it's identical to what you do today with your microservices, except your microservices is distributed using REST and so forth. This works inside the JVM. You have this thing called service registry. You store up a service, and you say register, and then someone finds it by using filters and uses it. And they operate on a common contract. And again, it's nothing like this in JPMS. So you can't really move to level 5 to be able to dynamically exchange services when you need to. So as I said, again, level 5 is not covered by JPMS, or very, very little covered by JPMS. So that's the reason why the shape is kind of like this. So it addresses some things, but not everything. And at that point, some of you are probably thinking, oh, wait a minute, all the Oracle guys, they did it wrong. You know, it's like, how could they do this? They didn't. Don't be worried. They didn't do anything wrong. Actually, they made a perfect modular system. Why? Because of this. Because of how you define modularity. For the modularity as Oracle defined it for the purpose of JPMS, they did a perfect solution. It perfectly fits the JDK and the problems that JDK needs to solve. Remember, JDK is built now with modules, but it's released as a whole system. Or wait, 3-4 flavors of it. But it's not that Oracle was going to introduce a new module independently every other month. No, you're still going to get the whole JDK thing released as once. So it makes absolutely no sense for Oracle and for JDK to version individual modules in a way that they can be distributed independently. And so that you can decide that my JDK 9 is going to work with this module from JDK 10, and so no, this is never going to happen. So from their perspective, versions are absolutely not needed, and that's perfectly fine for the JDK itself. It's not fine for you. So when you think about how they designed JPMS, you have to keep in mind the goals that they had and the problems they were aiming to solve. And as far as those are concerned, they designed the perfect modular system for the JDK itself. So it's just not a good fit for general purpose modular system to build applications. And that's why a lot of people who was dealing with modularity for many, many years are now expressing opinions like this, that when developers start using JPMS, they all of a sudden will realize the limitations and all of a sudden start picking other, more advanced, more mature modular systems. Honestly speaking, I'm not very confident this is going to be the case. But one thing is for sure, the focus of developers is shifted on modularity, and that's a good thing. That's a good thing that we now all are concerned about modularity. We all think about modularity. We argue about modularity. That's a goal that OSGI had and failed to achieve, and now Oracle is very close to achieve. So from that respect, it's a good move. So finally, there is one last question that I want to address is, okay, we saw the 5 levels, but then you may say, well, wait a minute, but I don't really want to go on level 5. Why would I? So that goes back to what's the reason for anyone to be modular in the first place? And the sense of modularity is dealing with not knowing. Okay? The reason you want to have modules is because you don't know what's going to happen in the future. And you want to be flexible, and you want to be able to address a future that will change. Okay? So to give you some examples, the company I work for, we built this platform which we give to people, and then they use it for whatever purpose they want. And so we don't know when we're building the platform what these people will be using the platform for. And we could sit down and figure it out. This is the intended purpose of the platform, and then we're going to hit the wall because people are going to be using it for something else. Okay? So the only thing we could do is basically acknowledge the fact we don't know and make it so that it fits whatever the use case is. Okay? So just to give you an example, this is how we do RESTful services. So if you build a RESTful service, all you need to say is that you require a capability, which is a Noise.js contract, and it's, the contract is Java JAX-RS in version 2. So that's your requirement. You need something that is capable of serving RESTful services. And then on the other side, you have a provide capability for another module that can come up at any place or disappear at any place, but it says, I do provide this capability. I'm an implementation of Java JAX-RS, and I can do this. I can serve RESTful services to people, okay? So now this other module is independently configurable. You can, put it on, turn it off, up to you. The moment you put it on, that other guy starts working. The moment you turn it off, that other guy goes, well, my requirements are not satisfied, so I can't do anything about it. Okay? And it doesn't matter what's the implementation, because they share a contract. So you want to use, I don't know, Jackson or whatever is the implementation of JAX-RS, up to you. Okay? That is acknowledging the fact that you don't know what people will want to do or what business requirements you're going to face tomorrow. Okay? You may, because I showed you in a previous slide some very obscure configuration, and you may be thinking that, okay, but that's at the price of like very complex thing. Not really. It all works with annotations. So basically, it's no too different than Spring. You just say add component, provide a few properties, and on the other side, you would have things like add reference that's going to wire things together. The difference between this and Spring is this is capable of adapting to services that disappear and appear at any time and rewiring things and so forth. So those are just very, very, very tiny little examples to address not knowing. Okay, so you need to acknowledge the fact that you don't know what's going to happen. And when you do so, then you need to optimize for predictability. Now, obviously, you can't predict everything. No one can. And that's a normal thing. But you can predict some things. You can predict, based on your experience, that developers will have different preferences regarding RESTful frameworks. Or you can predict that different UIs will be used by different people. You can predict that you're going to have a bunch of people that's going to argue between React and Angular and whatever is the JavaScript framework of the next week. You can predict a few things, and you can build those applications of yours in a way that you don't have to rebuild them when the world around you changes. So we call this agility. And in every talk that you go about Agile, you hear the main purpose of Agile is flexibility, it's predictability, and we apply this to all kinds of processes that we have as a company, and we structure our teams around stuff like that. And we all acknowledge the fact that this is a good thing. But when it comes down to building software, most people believe that once built, never changes. Or if it needs to change, we need to recompile it and rebuild it again. And that's, I don't know, that may be the case, but that may not be the case. So you need modularity the moment you acknowledge that there are things you don't know, that you want to be predictable, you want to design for predictability, and you want to be agile. Your application needs to be agile. And that is when you need level 5. So we do. You may or may not. And that is pretty much everything I wanted to tell you today. Shameless plug at the end. We do organize this conference, which is going to be in October, where we're going to talk a lot more about modularity. So if anyone's around Amsterdam at that time, feel invited. Or you want to submit talks also. Thank you, and hope it was useful for you and you learned something today. Thank you.